This is AP Calculus, Unit 6, and there is no really lesson number because this is an extra lesson. While it does seem to fit the unit guide for 6-3, I do not want to make this a formal lesson. You are here because you are the overachiever, because you want to learn extra stuff that the rest of the class is not learning. All right, so before I even begin teaching, I want to talk about how much this is worth to you on the AP test. So some basics, there are 108 possible points on the AP test. And in order to score a 5, you need roughly a 64%, which means you're around 65 to 76. The reason that the cutoff isn't perfect in between here is because it's very approximate. It changes from year to year depending on how everyone else did on the test. And here you have previous years, how to get a 5, what percent you need, how to get a 4, what percent you need, how to get a 3, what percent you need, and their averages. And so to get a 4, you need about 48 to 59 points. To get a 3, you need about 29 to 44 points. The reason I'm going over this is I'm trying to game the system. You don't really need to know everything. You need to know the main things in order to get that 5. You need the main things in order to get that 3. So by learning this, it's not saying, oh, now I can get the 5. By learning this, you can still get a 5. There's quite a few points between 65 or between, you should do the upper bound, between 76 and 108 points to still lose points from other free response questions and from multiple choice questions. You don't need this information. So other information, each free response question, there are 6, is worth 9 points each. And there's going to be a max of 1 differential equation question, a max of 1 question asking about this stuff, which means you might get 1 or 2 points if they even ask this differential equation question. So yeah, by learning the following material, you might get between 1 and 2 points more. Might. Really stressing that. And by the way, you shouldn't be taking notes on any of this until I actually get to the lesson. I should have said that at the beginning. So let me restate this. Unless you have mastered steps 1 to 3, and steps 1 was separate variables, step 2 was anti-differentiate and include that plus c, and then step 3 is using that additional condition, just plugging in x and y. Unless you've mastered all of those steps, you shouldn't even be watching this video. And what I'm doing right now is I'm teaching you how to get this 1 point right here, how to solve for y. Sometimes this can be 2 points depending on how hard it was. And note here, things I've been telling you, you get 0 out of 6 if you didn't separate your variables, stuff that I've already talked before. This is on the scoring guide that I'm pulling directly from, if you're wondering. You're still watching? All right, let's learn. So step 4, isolate. This is the optional step, and this is essentially getting y by itself. There are basically 3 steps here, and they're pretty general. There's a lot of wiggle room for what I'm actually doing here. But generally speaking, the first thing that you want to do is find c. Find c, the constant of integration, using initial conditions. And then you want to plug c into original equation. And then finally, rearrange formula to solve to get y by itself. So I'm just going to say isolate y. Isolate y. And if you don't like the word isolate, maybe I should have just rewritten get y by itself, because I have everything written in terms of x. There's no more c, and you just need to get y by itself. All right, so let's move on to the first of the 2 examples. So find the particular solution to this thing. So I'm going to go through steps 1 through 4. You already know how to do steps 1 through 3, so I'm going to go through that pretty fast. So this needs to be a fraction equal to a fraction. I'm going to cross multiply, and I'm going to get dy is equal to x y cubed dx. I need to make sure that my variables are grouped together. This y needs to be moved to the left, so I'm going to divide both sides by y cubed, and I'm going to get 1 over y cubed dy is equal to x dx. So now they're on the correct side. Let's go ahead and integrate both sides. Different color here to let you know that I am doing a different step. Integrating, and I don't like a fraction. We don't like fractions in calculus, so this is going to be integral of y to the negative 3 dy is equal to, keep that integral of x dx. And now I need to integrate. So this is going to be adding a power, so y to the negative 2, divide down, so negative 1/2. And that's going to be equal to x is going to go up a power x squared, divide down 1/2, and don't forget your constant of integration, plus c. Now I need to plug in, and that'll be step 3. So when I plug in, I guess you can technically say I'm doing the evaluation bar of x is equal to 1, y is equal to 2, x is 1, y is 2 from up here. And when I do that, this becomes, I'm going to move the y into the bottom. This is really 1 over 2y squared, so it's a negative 1 over 2y squared, and y was 2, so 2 squared. That's going to equal 1/2, and then x again is just 1, so 1 squared plus c. I've done steps 1 through 3. I have the majority of the points. If you come back and take a look at the actual scoring guide, I have 1, 2, 3, 4, 5 points out of the 6. 5 out of 6, what is that? 5 divided by 6. That is an 83%. I am definitely above the 64%. I can still get a 5 just doing that. But we're going on. So to do this problem, I need to solve for c. So I'm going to simplify this. It's going to be negative 1 over 2 squared is 4 times 2 is 8. Negative 1/8 is equal to 1/2 plus c. I'm going to subtract the 1/2 over, so c is equal to negative 1/8, and I'm going to subtract that 1/2, 1 minus 1/2, but I'm going to say that that's minus 4/8. So I have like denominators, so that means c is actually equal to negative 5/8. So I solved for c. I did step 1. Now I need to plug c back into the original equation. And I need to plug c back in at a very specific point. It's after I integrate and before I substitute. So I can make a note on the side too. So sub in c before, or maybe I should start with after. So after you integrate and before initial condition. And that means plugging in x and y. So that means I'm on this step right here. So plugging in, I have, well, not plugging in, before I plug in, I have the equation negative 1 over 2y squared. I just changed this a little bit by bringing the y down, is equal to an x squared over 2 plus, instead of c, I'm now plugging in negative, so it's not plus, it's going to be minus 5/8. All right, now I need to solve for y, and that can be the tricky part. So first I'm going to get rid of this negative and the 2. I'm going to multiply by negative 2 on both sides. And if you want to do that, I can say multiply by negative 2 on both sides. Negative 2 on both sides. So when I do that, I get a negative, not a negative, I get a 1 over y squared is equal to, and this is going to be a negative x squared minus, no, it's going to be plus 10/8. Perfect. Now, how do I get this y out of the denominator? I need to take the reciprocal of both sides. And be careful that you don't take the reciprocal of individual elements. You need to take the reciprocal of this entire sum. So when I take the reciprocal, I'm left with y squared is equal to this entire sum on the bottom now. 1 over negative x squared plus 10/8. And finally, get rid of the square by taking the square root. So I'm going to have y is equal to the square root. I'm going to do the square root at the end. I'm going to rewrite negative x squared plus 10/8. All of this is square rooted. And if you want to simplify a little bit, it's really square root of 1 over square root of this. So you can only do the square root in the denominator. If you want, it doesn't really matter. Before I even do that, I made a mistake. Whenever you do square root, it's going to be plus or minus. All right, so let me rewrite this a little bit differently in a second, but I need to talk about this plus or minus. You cannot have a plus or minus in your final answer. Let's write that on the side. Cannot have plus or minus in final answer. As far as all of the tests that I've seen, you need to choose one. One of these will be right, one of them will be wrong. How do you know? You'll know by plugging in your initial condition. So check using initial condition. And we're going to do that up here. So we need to choose plus or minus, and then we'll be done. So when I do that, I'm choosing my plus or minus. So I'm not really choosing. The way I'll figure it out is by plugging these in. So I'm going to plug in 2 for y. So it's going to be 2 is equal to plus or minus. And then I'm going to have 1 all over. Remember how I said the square root is only on the bottom. negative, and here's my x squared plus 10/8. All of that is square rooted. All right, let's see if we need the plus or the minus. Let's simplify this bottom part. So this is going to be 2 is equal to plus or minus 1 all over. This is going to be 1 squared is 1, and then negative times that is a negative 1. So I have a negative 8 over 8 plus 10 over 8. And of course I still have that square root in here as well. So I have 2 is equal to a plus or minus 1 over the square root of 1/4. So 2 is equal to plus or minus 1 over 1/2. And 1 divided by 1/2, and maybe I should have written this a little bit over here. 1 divided by 1/2 is the same thing as saying 1 divided by 1/2. So this is the keep it, change it, flip it rule. So this is saying 2 is equal to plus or minus 2. All right, can you tell which one we chose? Do we choose the negative or the positive? We chose the positive because that's the only one that makes sense. If I chose negative, I would have 2 equals -2. So I'm going to squeeze it down here in this corner. We have our final answer. Finally, we'll do it in red because it's our final answer. Y is equal to 1. It's a positive 1, and maybe I can do it like this. So I have room 1 divided by the square root of negative x squared plus 10/8. All of that was square rooted. Final answer. And I guess I should have simplified 10/8 to 5/4, but I still would have gotten my full credit for this by saying this answer, my full 1 point of credit. Let's go to example number 2. Find this particular solution to that differential equation. All right, here we go. It needs to be a fraction equal to a fraction, cross multiply. So I get on the left-hand side, I like dy's on my left, so dy on the left is equal to 3 minus y times cosine of x dx. Oh, look, I have a y on the right. I need to get it to the left. I need to divide by this entire term, 3 minus y. So I have 1 over 3 minus y. dy is equal to cosine of x dx. All right, now I need to integrate. So to integrate, there it goes like that. I don't like fractions, get rid of it, so it's going to be the integral of 3 minus y to the -1 dy is equal to integral of cosine, I'll just leave this, integral of cosine of x dx. All right, I look at my inner, the derivative of inner is -1, it's not 1, so I need to use taxman. When I pay the taxman, it's going to be a -1 out front. I can already see that, so I'm kind of skipping showing my work for taxman, but I know this is going to be a -1 times whatever this is, and that's going to be -1 times a natural log of, it's not parentheses, it's always absolute value whenever you have a natural log, absolute value of 3 minus y. That's going to equal, so cosine anti-change is same, so it's going to be the same sign, sine of x, don't forget your constant, plus c. All right, and then I need to substitute in, but here's the thing. So you don't actually want to substitute in yet because you want to do some work, otherwise you're going to come into an error, and you can try that on yourself, by yourself, and you'll see what your error is. You'll have some random plus or minus that you're not able to get rid of. By not subbing in right now, I will actually be able to solve this correctly. So I'm not going to sub in yet. This is kind of where I stray away from step 3 and I kind of work on step 4 before I do step 3. So what am I going to do here? I'm going to divide both sides by -1. So I have the natural log of absolute value of 3 minus y is equal to negative sine of x minus c. All right, so how do I get rid of a natural logarithm? So I have to get rid of the natural logarithm, and then I have to get rid of the absolute value. Both of those go hand in hand. They're hard to do. The process is called exponentiation, and that just is a fancy way of saying do e to both sides. So e to all of this and e to all of this. So my new equation is going to be the e and natural log will cancel each other out. That's kind of the rule of logs you have to remember. So I have e to the natural log of x. The rule is that is just equal to x. The e and the natural log cancel each other out. So they cancel each other out, and I'm left with absolute value of 3 minus y. I still have the absolute value. It doesn't change to a parenthesis. That's equal to, and I still have this exponentiated, which is e to the power of negative sine of x minus c. All of that is in the power because I exponentiated. All right, now I have to somehow figure out how to get rid of this absolute value. And if you remember from Algebra 2, you just drop it and then make this a plus or minus. And I can do that. So when I do that, it's going to be a 3 minus y. I dropped it, or I bent the bars if you want to think of this as parentheses. This is now going to be a plus. Oh, what happened there? It's going to be a plus or a minus e. And I'm going to change the form here because it's going to make it easier for me. I'm going to change this to plus or minus negative sine, get that s in here, sine of x, and then this is going to be times e to the negative c. This is just one of the rules of exponents that you need to remember, especially when it comes to dealing with natural logarithms. You'll almost always use this trick. All right, and then finally I can get y set to something. I'm going to subtract 3 and go ahead and divide by this negative. So there's two things that I need to think about before I even do this. And this problem is pretty tricky whenever you have a natural logarithm involved. There's two tricky parts. The plus or minus, somehow I need to get rid of that. I need to have a rule that gets rid of it without just guessing and checking like our last one. You could do that, and I did do that process. It is twice as long as what I'm about to do, which is already long to begin with, because there's a bunch of logarithmic rules that you need to remember. So this is the easy way, I promise. So this plus or minus needs to go away, and this c needs to go away. It needs to get substituted in, right? That was our step up here. We need to plug c into it to get rid of the c and just have an x. So these are two problem points, e to the negative c and this plus or minus. Let's get those all next to each other. So I'm going to do like three things at once, so bear with me here. I'm going to get y by itself. That means I divided by a negative to get rid of the negative, and I subtracted the 3. When I subtract 3, I get a negative 3, and divided by the negative is a positive 3. I'm going to do something a little bit strange here. This is going to be a 3, and since this was normally, I would say, a plus or minus, all of this stuff, I'm going to say, now I'm multiplying by a negative, so this is going to be 3 minus, and I'm still leaving this plus or minus. It looks really weird in the notation, but I promise it works out. Plus or minus, and now I'm going to switch these two. Because it's just the multiplicative rule of association or something like that. You can just switch these two because they're being multiplied. Plus or minus e to the power of negative c times e to the power of negative sine of x. All right, hopefully I haven't lost you so far. You see how I got from this step to this step. Now, here's where the trick comes in. I mean, there's already a lot of tricks, but this is like the mega trick of them all. This thing right here, we don't know anything in there. We don't know what c is. I mean, we do know what e is. We don't know what the plus or minus. Is it plus or minus? Let's just treat this whole thing as box. You can think of it as a variable if you don't like the name for box. But I'm just going to say that is equal to box. So my equation, if I come all the way up here and keep working, my equation now says y is equal to 3 minus box times e to the negative sine of x. And the reason I'm doing that is because I'm containing all the things I don't know with this one box, and then I'll figure out what that box is in a sec. I can figure out what that box is if I plug in my x and my y. If I plug in x and y, notice that the only thing I don't know is the box, and then I can get rid of the box by plugging it back in for here. So it saves a bunch of extra work just by making this cool little box. So let's plug in. We're going to evaluation bar this thing when x is equal to 0, when y is equal to 1. So plugging in, I have 1 is equal to 3 minus box times e to the power of negative sine of 0, subbing in that 0 for x. Sine of 0, that should be 0, so negative 0 is 0, e to the power of 0 is 1. 1 times box is just box. A lot of mental math there. So I'm just left with box here, and my new equation is 1 equals 3 minus box. How easy is that? Okay, now we of course need to solve for box. So however you want to do that, I can subtract the 3, get negative 2 divided by negative, so 2. That's what our box is equal to. How beautiful is that? Because now we can just say, this whole thing, don't worry about this plus or minus, don't worry about the c, don't worry about the e, this whole entire thing is just 2. And that's what we're going to do. That's the equivalent of us plugging in our C. It's using this box trick. So now I'm plugging back in. So I'll do a little squiggle. We're plugging back in, and this is going to be y equals, I'm just copying down this line right here, 3 minus, and now we know what our box is. Oh, what happened there? 3 minus, our box was 2. 2. And that's going to be multiplied by this e to the negative sine of x. All right, and we are done, finally. And we don't have to worry about anything. We're deciding, like, is it plus or minus because of this box technique? And that is our final answer. You will almost always use this box technique whenever you have a natural logarithm when you're getting your evaluation. When you're doing the antiderivative and you have a natural logarithm, you're going to be using this trick. All right, I know that was challenging. There are a lot of tricks in here. There would have been even more tricks and a longer problem if we decided to plug in immediately, but those are our 2 examples. And again, hopefully you have been turned back. I know that sounds bad, but hopefully you have turned back and said, okay, I'm going to spend most of my effort focusing on these first 5 points, and I don't really care. That's 1 point, maybe 2 points, if it's even asked, and I'm going to game the system and not spend my time learning the extra stuff. That is my hope by the end of this video. All right, but I do appreciate you guys watching all the way through to here. You are devoted. You are that overachiever. Thank you for watching. Even if you did turn back, I still appreciate you watching my video. So thank you, and I will see you later.